Hey everyone, happy to be here with you tonight. My name is Emily Sousa. I'm a co-ambassador for the Seattle chapter of Women in 3D Printing, and I'm a additive manufacturing engineer in the aerospace industry. I am a brown, short brown hair. I'm wearing a gray sweatshirt tonight for our visually impaired audience members, and I use she/her pronouns.
Yeah, and I'm Michelle Wilkins. I am also a co-ambassador for the Women in 3D Printing Seattle chapter. I'm also the project manager of industry development for the Society of Manufacturing Engineers, also known as SME. You can identify me for the visually or for the hearing impaired. I'm the one with bangs. And I have 3D printers in the background in case you notice those, and I'm wearing a black shirt. I go by she, her pronouns, and yeah, excited to be here.
Okay, if we're ready to get started, we can go to the next slide. So here's just our brief introduction slide. As I said, again, my name is Emily, and I'm here today with Michelle. If you can take us to the next slide. Thank you. So 3D printing, it's everywhere. It's super popular in this day and age. Within the past decade, we've seen an exponential growth of 3D printing, both within the hobby and the DIY spaces, as well as the professional industry. The home market, we see a lot of use for cosplay, DIY fixes. People are even printing board game components and minis. I myself have used it for custom vehicle components, supporting some of the electrical accessories I install. And some of the really cool things we're going to talk about today are how people have makers, DIY enthusiasts have started to be able to actually make money off of their prints and their hobby by starting small businesses. And even within Women in 3D Printing recently, we had a lot of community printed adapters for water bottles to convert like your regular water bottle into actually a portable shower for people that have been victims of the hurricanes that we've been seeing on the East Coast lately. So tons of uses within the DIY at-home space. And then on the industrial side of things, 3D printing is becoming even more popular within industries like aerospace and automotive. Even more exciting things that we're starting to see, new industries implementing 3D printing. We see things like fashion implementing 3D printing, things like 3D printed textiles, and we're also seeing it in construction. There's companies that are building these massive concrete printers, printing livable structures within hours. And then on the slides here, I just have some cool pictures. On the far right, we have an Overwatch cosplay outfit that was 3D printed, the mask and the weapon, and then an example of some 3D printed fashion. And of course, the bottom picture is an example of some metallic added 3D printing that we will get into a little bit later. Next slide, please.
Yeah, so I just wanted to do a brief introduction. This is, if you want to learn more about 3D printing or kind of see somebody local, how they implement it and utilize it. Joel Telling with 3D Printing Nerd on YouTube. I highly suggest you follow him. He's a great resource to watch and see just what the technology is capable of. If you want to play the video, I got a fun little snippet with Felicia Day after this commercial break. Yeah, like I was saying, he's local to Seattle. He's very much huge in the industry, and
life's better when you're under our roof. Save up to 23% by bundling your home and auto with us.
American Family Insurance and spooky good deals.
And then we sent that off
There we
to
go.
Galactic Armory.
Galactic Armory, who does incredible work. They do mostly, I think, Star Wars stuff. Oh, it's just breathtaking. Their work is breathtaking. So I was so excited to have them on board here. This is like
With Galactic Armory on board, they took their time and took the photos for scale and created a set of armor for you.
Yes.
And sent it to me and said, here you go, Joel. You can 3D print this.
I'm very excited.
I'm
very
Let
excited.
me go get it.
Oh, why are they pink? Oh, they're so pretty.
I know that the goal is for Felicia to finish these.
Oh yes, I'm going to paint them because I have recently been introduced. I work with Felicia Day 3D. I work with a wonderful mini designer, Moonlight Minis, and they introduced me to Reaper, who gave me all these paints, and now my daughter steals all the models to paint herself. So this is good. They're away from her, so she can't volunteer to paint these, like, you know.
These are made on the Bamboo Lab X1 Carbon. Wow. Same machine that you have. Same machine I have. Absolutely same machine that you have.
This is so cool. Now, why did you pick these filament colors? Because you were just
because
wanted to get rid of them?
Well, they were already loaded, and
so
I knew you were going to paint them.
Okay.
I could have made pink armor, but I also thought.
So you might have heard him talk about a little bit in here, Galactic Armory. They do a lot with 3D printing. You can purchase fully developed and assembled like cosplay weapons and helmets. They very much specialize in Star Wars cosplay props, as they mentioned in the video. And you can also actually buy their 3D printed their files so that you can 3D print the parts at home and assemble them. They're very much in the Patreon startup state, so I highly suggest if you're interested in either purchasing a completed weapon or want to purchase the file and assemble it yourself for your next cool cosplay, they're a great resource for that. Next slide, please. These are just another couple examples of industrial 3D printing. There are honestly so many use cases in the additive manufacturing and 3D printing industry that it's difficult to cover them all. Like on top of these, that we also have circuit board printing, but on the left, you'll see a hotel, which is the first 3D printed hotel that they just did down in Texas. So it's very much material extrusion, similar to FDM printing that you may know, but on a very large industrial scale. And on the subject of fashion, the image on the right, 3D printing is also very much being used for orthopedics as well as shoe design to kind of create that custom sizing for anyone that just maybe doesn't fit these average sizes. Next slide.
So you maybe have heard Michelle and I kind of drop the term additive manufacturing, or maybe you've heard it kind of thrown about in technical spaces. So what is additive manufacturing? It's really just a fancy technical term for 3D printing. It's usually used in a more industrial, professional setting. It's called AM for short because additive manufacturing is a little bit of a mouthful. It distinguishes itself from traditional manufacturing, where you're subtracting material from a big brick to get your desired shape. So our goal in this section here is going to be to introduce you all to some additive manufacturing methods that you might not necessarily be familiar with because they're not always accessible for the home user. When we start to hit the industrial scale, the professional scale, we actually start to see metallic additive manufacturing, which is 3D printing parts that are metal. And so we'll get into that a little bit more later. And AM at the industrial scale has allowed the creation of these ultra complex components that we just simply wouldn't be able to achieve with traditional machining, which is why it's so attractive of an industry. And so what do I mean when I say we're achieving these new ultra complex components? With something like rocket engines, for example, the component designers are able to build more ideal internal structures like flow channels and vanes to make the rocket operate more optimally. And maybe the way that they're hidden away deep within the part, you wouldn't be able to get to those and machine those or create those with casting normally. And so that's why it's so exciting, and we're starting to see so many advancements with like rocket performance and things like that. So there's 7 main types of additive manufacturing 3D printing. Michelle and I are going to be touching on some of the most popular and our favorite ones. There's material extrusion, vat photopolymerization, material jetting, powder bed fusion, binder jetting, directed energy deposition, and then sheet lamination. Sheet lamination is actually a composite process. It's the laying up of composite material layer upon layer. So we won't be getting into that one tonight, but just for everyone's awareness, it is a AM process that's out there. Next slide, please.
Yeah, so material extrusion is probably the one, if you're familiar with 3D printing at all, you probably recognize a lot of the machines here. You can kind of actually see some behind me. The Ender 3 is a very standard, affordable FDM machine, which FDM just stands for Fused Deposition Modeling. Additive manufacturing 3D printing is very much an industry of alphabet soup, so you'll hear a lot of different acronyms thrown around. Just don't get too intimidated by them. A lot of them are pretty much only used in the industry, but FDM, and then there's also PDM, which is just pellet deposition modeling. And the only real difference there is that one uses filament and one uses like pellets of polymers to kind of melt down and build layer by layer. So this is, if you do any cosplay 3D printing, this is very much the standard, most average, or most used process. There are 2 different types of filament you can use for a standard FDM printer. You'll see PLA and ABS, again, adding to the alphabet soup. They're very long, just material names. I won't necessarily go into those and confuse you more, but ultimately, when you do want to choose between, if you do decide to purchase a 3D printer, an FDM 3D printer, and you're trying to figure out which filament you should get, PLA is the most standard, and it's because it's more silky, kind of has a better finish. It's more environmentally friendly than the ABS option. And ABS you would really just use if you want like stronger material properties or mechanical properties, and you're using it for more something that's not going to be seen, and you want something that's a little bit more resistant to heat and fire. It's not fireproof. I just want to give that disclosure. It can still melt. It's just the melting temperature is a lot higher than standard PLA. So that's something to consider when you are building any props for your cosplay. If you're going to be around hot conditions and don't want to melt, ABS might be standard, or if you have fire coming out of anything, probably still want to get it fireproof, but that would be the material that would withstand the heat more. And to kind of explain more about what FDM is, if for those who don't know, it's basically the filament is fed through a nozzle, and it heats up at the nozzle and kind of builds the part layer by layer. As cool as this is, it is a long process depending on how large the part is. So expect it to take like a few hours, maybe even a day to actually finish the part, depending if you're like building that Iron Man helmet, for example, that's probably going to take 24 to 48 hours, depending on what machine you have. And I would also say, if you want to get more industrial and build bigger parts, they do have large scale FDM printers and pellet and PDM printers. They kind of range more in the $2,000, $8,000 range. But if you're planning to open your own cosplay business and you got a business license with that money to spend, that's a great option so that you don't have to build different parts and assemble them. You can kind of just build one large part and be done with it. Yeah, next slide. And the other polymer type, this one is more commonly used if anybody has printed miniatures for tabletop gaming, such as Dungeons and Dragons or Warhammer. This is very much a standard. It's called, I always call it SLA, which is stereolithography. Again, another part of the alphabet soup, or digital light processing. And essentially what that means is, unlike FDM, where you start on a flat build plate and build up, the build plate will actually come down and soak into a bed of resin, and then the UV light will cure it as it builds layer by layer, and it will come up as you see in the photo on the right. This one is very much known to have supports. So kind of has a lot of post-processing, meaning you have to remove all those supports, and you have to kind of know upon the build in the CAD file you use that you need to know where to put those supports. You can find a lot of those CAD files online. I use like Light G Slicer, and there's tons of different SLA or STL files is what they're called, that you can kind of use to build those parts. And actually with SLA, that's another part of the alphabet soup. You get STL files would be for more FDM, and then PWNA would be more for like photopolymerization. And I highly suggest if you're looking at investing in a 3D printer that you would, there are definitely resources you could look into to kind of get a lot of that information, since it is quite a learning process. Yeah, so this is great for cosplay. I would say if you're not having a large scale 3D printer, you would likely do a lot more with assembly. I actually have some examples too. This is what we call benchy. It's what you kind of use to benchmark or set your 3D printer so that you know that it's going to print correctly. That way you're not wasting hours of time just to have the part come out not the way you want. And to give you an example of what a failed FDM print looks like in a problem, this is my little astronaut. It's a little watch holder. I don't know if you can see it, but there's some flailing and like strings hanging off of him. Usually it's a problem with heating the bed and heating the nozzle. So that's a lot of post-processing you have to do. And you also kind of have to think about the strength when you go into the programs and set the print, because they can be brittle and weak, and like this poor guy whose leg fell off. Yeah, so that's kind of a brief overview of a very large process with polymer printing. We can actually go to the next slide. And this is another process, and this one you won't see sold often for desktop 3D printers. This is more used in the kind of more industrial setting, but this is used for very high quality prints, and they use it for polymer. It can actually now be used for metal as well through new inventions called multi-jet printing, polyjet printing, and this one is great for doing multicolor printing. So one of the restrictions with FDM and SLA, the stereolithography processes and the fused deposition modeling process mentioned before. One of the restrictions is they don't really support multicolored printing. You kind of have to stop the print and change out the filament to get multiple prints, or you have to buy a filament that has that built in or is built to be multicolored. So material jetting fixes that, because it can build strong materials and it uses multicolor. And the difference between this one, SLA and FDM, is that it's very similar to the SLA you saw with the resin bed, except instead it has a bed of powder, or just like a resin bed that cures as it does droplets layer by layer. So instead of building up, and you don't need supports for it, it just kind of builds up layer by layer, similar to an FDM machine, but it just does it drop by drop instead. And I actually have a couple of examples. And one of the reasons why material jetting is a great process. So this is actually a fidget spinner that was used with this material jetting process. It's by HP's multi-jet printer. HP makes 3D printers on top of paper printers, by the way.
Their 3D printers actually work though, right?
They do, yes. Well, I mean, subject to opinion, but yes. So HP is actually a huge distributor for the jewelry and casting molds industry. So basically, this process is very much used to build molds to create high-end jewelry you might see, like Chanel and all these other companies will use, whether we realize it or not, utilize 3D printing to build their molds so that they can kind of withstand that high heat and temperature of the melted metals as they develop their process for casting. And then this is also very much commonly used for medical models, so prosthetics, and like I know some dental industries use this as well for like some molds for kind of like examples that you might see at a doctor's office or a dentist office with like a model of like dentures, or at a hospital with like one of those skeletons. This is often used for a lot of those like props. So if you are interested in doing large scale 3D printing or really intricate 3D printing for cosplay, and you're starting your own business, this is definitely a good machine to invest in for that. Next slide.
Okay, so now we're moving on to the metallic side of things. This is super cool to me just because I feel, one, this is the kind of work I do, so obviously I'm a huge nerd about it. But also this is not necessarily accessible to like the general consumer market, so I think it's really exciting for you guys to get to learn about it tonight. So powder bed fusion is definitely one of the most popular metallic AM methods being used in the industry because of the capability to achieve complex geometries, as mentioned earlier, and it actually achieves a pretty reasonable surface finish if you just like need a rough like net shape part. It's pretty heavily used in aerospace, automotive, general defense, and medical industries for like implants and stuff like that. And the way that it works is it lays down a layer of powder, which you can see it doing right now in that video on this side. And it lays it down on a build platform. It blasts it with a laser. And then once it's done scanning the cross-sectional area of the part, similar to the way that you print like in cross-sections for like home 3D printing. And then it'll finish lasing, and then it will swipe powder back over after it the building platform moves down, and then it'll swipe that powder back over. And this building platform is moving down just ever so slightly, little tiny increments, basically the thickness of the powdered layer. And honestly, it's impossible to see. It feels like it doesn't go anywhere, but obviously it is, because it's not just building up to the top of the chamber. Super cool process, really really complex geometries that you can achieve with this. Maybe something that you can't see in this video is that similar to some of the processes Michelle talked about, you do have to utilize support structures for like overhanging features or really like unique geometries. Within this same category, there's also direct metal laser sintering and selective laser sintering. The main difference here is in sintering, the powder is subjected to heat and pressure, which causes the material to join together. So it's being heated up and kind of squeezed together within the pressurized chamber. But unlike laser powder bed fusion, the powder is not actually fully melting. In LPBF, it's fully melting and then re-solidifying. So if you could go to the next slide. And then we'll play this video. This is from the Titans of CNC Machining. They do a lot of really cool manufacturing videos. Go ahead and...
Welcome to the first episode of our tutorial series on building a website from scratch using Wix Headless.
There we go. So this is a really cool video just kind of showing more of the whole process. So right at the
Most of
beginning, you
everything
can
we
see
interact with on a daily basis
the
has been designed
operator
and
is
manufactured by a person
kind of
or a
vacuuming
group of
powder
people.
off.
But what if we
So
left
the
the designing up
part
to
essentially is
artificial
getting buried
intelligence?
in
What would
powder
that
as
look
it
like? Today
moves
we're going
farther
to put
down
that
and
to
it's
the
completing the
test. We're going
build.
to 3D print a
And
part that was entirely
so
designed
they,
by
the
AI. How many
operators
hours will
can
this save
vacuum
us?
this
And
powder
what are the
off.
benefits of
Some
using
machines
AI to
even
design
pick the
parts?
part up and
And
just
oh
kind
yeah,
of
one
turn it
last thing.
and let
We're
all the
going
powder
to 3D
fall
print the
off
part
that
out
way.
of titanium.
There's 100
Yeah,
pounds
and
of
so we can
titanium
be
inside
done
of
with
this
this video
box.
here. We just kind of wanted to give you an idea of what this machine might look like, and kind of what general operation is. So if you could go to the next slide for me.
Yeah, so we just wanted to touch on, we talked a little bit about careers, like if you wanted to start your own 3D cosplay business and get a business license, invest in some of those larger scale machines, or even just get started with some of the smaller ones you see behind me, because that is possible with just a lot of assembly, and that people do it all the time. But there are other jobs available, especially if you're interested in going into more of an industrial 3D printing or additive manufacturing career. And you don't necessarily have to be an engineer or go to get like an engineering degree for it. There are actually a ton of training, education and training resources you can go through without even getting a degree. And I'll go over that later. But here are just a list of some other jobs available in additive manufacturing. Machine operators. So like you saw the guy operating and 3D printing that rocket engine part using titanium. It's a lot of people, when they think of machine operators, they think of it's dangerous, it's dirty, or it's like kind of like a high stress environment, which isn't really the case in additive and isn't really the case anymore with all the automation, especially as AI becomes more and more integrated. Design engineers is another one. There's a shortage of design engineers who can do design for additive manufacturing, which is essentially 3D CAD, like building parts and actually like making it so they can get transferred to the machines and print it in real time. So there's definitely a shortage there. Same with AM process engineers, which is similar to kind of machine operators, but also more kind of looking at the materials and the more scientific side of it. Project managers, product marketers, those are all, I mean, like any industry, you need those people to push machines, sell machines, you need them to build machines. That's always going to be a need. Same with marketing operations, sales and distribution. And because additive is still fairly new, it's technically been around since 1986. You may have seen it in the opening scene of the movie Small Soldiers, which was the first time it was used in Hollywood. The opening scene where they're 3D printing the action figures by, I think it was 3D Systems. So that's one example. But anyway, research and development managers, because it is a fairly new technology and it's constantly growing and developing, it's very high need. And software developers for all those CAD, CAM, and I have DFAM there, another part of the alphabet soup, which just stands for Design for Additive Manufacturing. So a lot of data entry, data security, data analysis, and I didn't even mention, but finance, accounting, all of those are needed within additive, and it's very much a growing market, and there's a shortage in that career field. So if you're looking to branch out and you're passionate about 3D printing, those are also other opportunities available.
Yeah. And then I was mentioning how we would talk about resources. So I work for the Society of Manufacturing Engineers. That's pretty much our big mission statement, is to bridge the gap in employment for manufacturing in general, but additive being a big one. If you want more resources and articles to learn more about the back end and the more industrial side of 3D printing, I would recommend advancedmanufacturing.org. They have a wide range of articles in not just additive, but also in regular manufacturing, such as CNC machining and just like aerospace, automotive, and all the use cases and how they're using 3D printing. You can find resources there.
As for training and education resources, you can actually get one of the things I was mentioning earlier without a degree. SME also offers additive manufacturing certifications. So we have like our certified additive manufacturing fundamentals if you just want to learn about the industry and be able to get a job on like a project manager level. That's what I actually do. You can do that. And there's also the certified additive manufacturing technician if you want to learn more and get certified on the machines and the technical side of it. We also have our Tooling U SME workforce development training. We have like VR headsets that can actually show you how to do welding, fabrication, additive, all of that just via a VR headset. They also have a ton of workforce development training options available. And then as for local resources, you can join our chapter, the Women in 3D Printing Seattle chapter. We also have the Society of Manufacturing Engineers also has a Seattle chapter. It's called the Seattle Chapter 39. So if anyone's interested in becoming a member, that is also open to anyone who's interested or in the industry. And then Seattle Makers is actually a very great local facility that you can go to and you can check out machines. They have 3D printers in their facility. They have SLA, FDM. You can go and play around with them. They also have laser cutting. They have a wide range of like manufacturing and DIY machines you can utilize and try out for yourself if you're thinking about investing in a machine but you're not quite sure. They can teach you. They have workshops. It's a great local resource. If you're going to the University of Washington, they have an additive manufacturing facility as well, which is part of their manufacturing degree program. But I'm sure if you reach out and want to view their facility, they'll be more than open to letting you tour that because they're always looking for people to enter that field. And then Edmonds College, I actually started with their degree. They have advanced manufacturing and materials engineering technology, and it's a bachelor's degree that you can take there if you do want to really dive deep, not only in additive, but in advanced manufacturing in general. So highly recommend all of those. Next, so yeah.
So Michelle mentioned you can join our chapter of Women in 3D Printing. And so just to kind of talk about what Women in 3D Printing is about, we are on a mission to make the 3D printing industry reflective of the world in which it operates. Women in 3D Printing is a movement of individuals from all over the globe, from diverse backgrounds, gendered identities, and socioeconomic statuses who are coming together to have a stronger voice within the additive manufacturing industry. Initially, Women in 3D Printing was founded to drive towards gender parity and creating and supporting a diverse, equitable, and inclusive environment. Because we realize that a more equitable and inclusive environment is a more innovative one. And Women in 3D Printing is all about ensuring that nobody feels excluded while working in, learning about, or being inspired by 3D printing. Next slide, please. So what do we do within the Seattle chapter? We are a local community of 3D printing enthusiasts and professionals. You have Michelle and I here tonight. We also have members that work at companies like Blue Origin and Relativity. We like to host happy hours, networking events, and we're always looking for new ways to encourage interest in 3D printing. Michelle, any closing marks as well?
I think you covered most of it. I will just say if anybody does want to learn more, you can also follow me on LinkedIn. I would be under Michelle Wilkins. Feel free to direct message me, send anything if you want to learn more about the industry or any of the resources mentioned. Yeah, I think that's pretty much it.
So yeah, we are happy to turn it over to questions from the audience if there are any. Does anyone have a favorite technology that they learned about tonight?
SLA.
SLA, cool. Yeah, Michelle, I actually didn't know very much about material jetting. That's pretty cool.
Yeah, it's a lot. It's a lot. There's a lot there, and then there's also like binder jetting and things that complement it. But I didn't want to download too many different alphabet soup terms.
Of course.
Yeah.
It looks like we have a question in the chat. How did we get interested in 3D printing? Michelle, would you like to start, and then I'll follow up?
Sure. Actually, it was kind of non-conventional. I was doing entertainment events, especially I was actually in the gaming industry, starting out doing esports events and production there. And of course, once COVID hit, all of that stopped. So I kind of had to reevaluate my career. I ended up doing some HR, like contract gigs, but I ended up finding a job opening with a local company called Dendrite. They're a software company for additive manufacturing. And I started as a marketing coordinator there because they needed some marketing support. And I got to learn all about what additive manufacturing was. Like when I started, I didn't even know that 3D printing and additive manufacturing were synonymous or the same thing. And I got to go to major events like Rapid Plus TCT, which is a huge additive manufacturing expo and convention that takes place every year. And then I got to go to like Formnext, which is out in Frankfurt, Germany. So it's a huge market, and there's constantly conferences and events. But going there, I got to see all these machines in action and meet with the industry and talk with them, and kind of fell in love with it. Started pursuing a degree in advanced manufacturing, and ended up landing a job with SME, Society of Manufacturing Engineers, to support that industry and kind of help it grow. So it became a passion project that stemmed from gaming and cosplay, and actually went and expanded to additive.
Yeah, and I got interested in 3D printing. One of my professors in college was like, "Hey, you should check this this technology out. It's the next big thing. I keep telling everyone to learn more about it." And so I was like, "Okay, sure, whatever." But I looked into it and I was like, wait, this is actually super interesting. This is super cool. We're pushing the bounds of what's possible. And so I was actually working in a different industry, still aerospace, but actually more on the carbon fiber side. And so I took some classes relating to additive manufacturing to learn a little bit more about it. And, from that moment on, I was just all in. I really see it as the future. Traditional manufacturing still has its place, but I think for a lot of the crazy initiatives we're seeing from space companies and industries these days, I really think additive manufacturing is what's going to get us there. And then, something that Michelle and I didn't really touch on during this presentation is that additive manufacturing can also be really eco-friendly because there's essentially zero waste. And that's something that I'm really passionate about as well. Pursuing a cleaner earth, a better earth, and supporting the environment. So that's kind of what brought me into additive manufacturing. Let's see, another question. Oh, from Sir Maldog. What is my favorite thing about working in the metals AM industry? Yeah, so as I mentioned, we really get to push the bounds of what's possible with additive manufacturing. And I really love knowing that I'm a part of something very novel and cutting edge. I work with rocket engine designers, and within the aerospace, there's a lot of people that are really sold on the traditional methods, and they'll say things like, "Oh, you're not going to be able to do that. We can't make that." And it's like, well, actually, we can with additive manufacturing. And we'll make it, and it'll outperform everyone's expectations, and it's just a really good feeling at the end of the day. What is our favorite thing you've ever 3D printed? Michelle, do you want to start?
Or weirdest. Honestly, I haven't personally printed too many things that have. It's still been a work in progress for me to kind of learn how to print things perfectly. I actually have an example of an SLA gone wrong. You can see his hands are very thin, and I didn't get the sizing of the base right. It's probably the weirdest thing I printed. But I will say, like, I could say my favorite thing ever printed, and this is something I didn't really touch on, is additives taking a big step in bioprinting in the medical industry. So they're 3D printing human stem cells like hearts and like basically custom fittings for kneecaps and body parts like that people need implants for. Like I'd say I'm more living vicariously through the engineers, seeing all the cool things that can be printed and what has been done. But yeah, I'd say the weirdest thing I've printed was that interesting astronaut.
My favorite thing that I've printed, this one is not necessarily, it wasn't anything super complex, but I have a friend who owns a business, and I 3D printed out of metal a custom keychain for his business with his logo, and it was just really cool to be able to give that to him as this like super special, unique, one of a kind thing, and that's something you really only get to do with additive. Any other questions tonight? I saw someone ask earlier about the type of printing from Ocean's 8. Yeah, I don't know. That might have been material jetting. That's a good question.
I am lame and have not seen that movie, so I can't speak to it, but I will now have to watch it.
Yeah, absolutely. If I remember correctly, they use it to 3D print a decoy necklace for like the crown jewels or something that they steal.
Yeah, likely. That sounds like material jetting, maybe metal material jetting or binder jetting. Both binder jetting and material jetting have similar machines, so it could have been either one.
Well, awesome. There any other questions this evening?
Fashion printing still very niche and expensive. I would say it depends on what machine you're using or what you're trying to print. It's very much based on use case. If you're trying to print jewelry, those material jetting machines and binder jetting machines usually range anywhere from like 8 to 30,000. So those are pretty pricey. I would say, but I have seen people like a lot of the like fashion and shoemaking, and you can actually 3D print jewelry using a FDM machine, and those are not very expensive. You can find like the Ender 3 I have behind me is a type of machine, and it was like $150 on Amazon. You can find even higher quality FDM machines for up to like 5,000, but they range from like the $150 to $5,000 range. I would just recommend if you are looking to get into the industry, you just do your research on what exactly based on what you want to do and the use case you want to use it for. And then recommend either going to Seattle makers and testing out some of their FDM and SLA machines, and kind of getting a feel for them. But yeah, I'd say if you're trying to do industrial like metal 3D printing, it can get very expensive, and it's very hard to get a license for a lot of those because they are heavily regulated. To get a business license for like the laser powder bed fusion machines, for some obvious reasons of you can print some very high strength weapon parts that the U.S. government doesn't want to release that power to the general public. So there are restrictions with a lot of the metal 3D printing machines. However, you can fit an FDM machine to print metal. It just takes high temperatures, and you kind of have to do your research on how to make that, like what materials to use, what temperatures you need, how hot your print bed needs to be, and things like that. So I'd say for jewelry making, it really just depends on what type of jewelry you want to make.
Yeah, definitely. And within like clothing fashion, I've seen designers like 3D printing textiles. So they like, it's like a plain sheet and then they'll 3D print on top of it, and it creates this really unique sort of like fluid material. The closest thing I can kind of describe it to the way it moves is kind of like chainmail. If that, it doesn't look like chainmail, it looks much prettier, but that same sort of idea. The other question we have, Michelle, is if you could have $150,000 in fancy 3D printer only money, what type would you like? Big one with plastic or multi-type?
Hexothermic is asking this one. Yes. I mean, for $150,000, if I could choose any printer that's not in that budget, because I would want like a laser powder bed fusion, which run about $500,000 to $1 million, and it's why they're exclusively used for aerospace defense and things like that. But $150,000, I would definitely go for probably a material jetting or binder jetting, a higher use case one, honestly. For that price range, I could probably afford one of those, and then a large scale FDM or SLA printer, so you can print like bigger materials. Like I've seen some that can print car, like body parts of a car. Like they range in size, they greatly range in size, and they're, at least for FDM though, they're not that expensive. Like they range from like $8,000 to $15,000. So I'd say I could probably fit a lot for $150,000, but that's not enough to get the high-end machines that I actually want.
Yeah, I think I'd have to say the same, Michelle. Or maybe I'd get a really like a really nice FDM and then blow the rest of the money on converting it to metal, and doing some sort of metal extrusion. That might be kind of fun project. And I'm always collecting new projects, so never finish them, but just always new ones. Let's see, not sure if this was already touched on, but are there 3D printers for metal printing which are practical or accessible for personal use? The sorry, I'm laughing at a message in the chat. There, not that I know of off the top of my head, but as Michelle mentioned earlier, there are hobbyists that are attempting and have successfully converted their home polymers printers to metal.
Yeah, I'd say that's the best option. I believe it's called Matter Hackers. I'm trying to remember the actual, there's a company that does sell fixtures that you can build onto your FDM printer that will allow you to print metal, and there are filaments for metal. The difficulty with it is that you kind of have to have you kind of have to do your research and knowing what prereqs you need to set in the file to make sure that it actually meets those standards, like what size filament you need, like how hot you need the nozzle, how hot you need the bed. And one problem about metals and FDM, at least on desktop 3D printers, is that metal has a very high melting point. So getting your machine hot enough and kind of fixing it to do that is a struggle. I'd say like the best option would be a binder jet or material jetting printer, which is not super accessible, but it's definitely more accessible than a laser powder bed fusion for $500,000. But like I said, those run about $8,000 to $10,000 on the lower scale. So they're not completely unattainable. And I know I've seen some on eBay even that people sell that, and a lot of the binder jetting specifically, they do 3D print metal. You just have to know the qualifications and know how to use the machine, which is another challenge. But there are plenty of resources and YouTube videos and things like that that can teach you. So I'd say if you're serious about metal 3D printing, material or binder jetting would be your best bet. Maybe we can all win the lottery. That would be great.
That would be perfect. Or we do an Ocean's 8, do crime together.
I see a question for you, Emily, if you want to answer.
No, I think we all know the answer.
Any other questions? We have about 5 minutes left. Can we print a 3D printer?
I think that's actually what Prusa does. Isn't that? Some of the components are 3D printed, and then it's just like a self-sustaining factory of like making the product they sell.
Yeah, I mean, it's not impossible. In fact, there's books. I don't know if anyone knows Ada's Bookstore on Capitol Hill, but they sell how-to books on how to build your own CNC machine and how to build your own 3D printer. And they're actually not super difficult. Like, they have them for kids, because especially the FDM machine you see behind me, it's not like you need to learn a little bit of electrical and a little bit of technical knowledge, but for the most part, they're actually pretty easy to build. So you can technically 3D print a 3D printer, especially the casings and the parts for it.
Yeah, and I think people really get into like modding their printers by printing their own components as well.
Yeah, you can definitely modify your 3D printer just like you can modify your car or pretty much anything.
Fave 3D printing video game. I don't, are there any?
I mean, I guess
Tetris? Does that count?
I know Satisfactory is like a factory machine game, but I don't know exactly how much 3D printing specifically is in it. I've just started playing it, so.
Oh, nice.
Astroneer. Okay.
I'll have to check that one out. Okay, well, if there's no last minute questions, it's been super great being with you guys tonight, and thank you for hanging out with us and listening to us talk about 3D printing. Please check out Women in 3D Printing Seattle. We would love to have you at an event.
Yeah, and I will also second that and say to also check out SME Seattle Chapter 39. We always do site tours. We go to like Boeing, we go to Fanuc. There's a lot of manufacturing factories that we go and tour and kind of learn about both their 3D printing and additive processes, but also other traditional manufacturing as well.
Thanks, everyone. Good night.
Thank you all.